let's get started with part two. So part two, well, part one we actually covered what is a mole. We're going to start getting ready to convert moles to grams, grams to moles, and to atoms. Before we do that, we need to talk about conversion factors. So knowing if here, conversion vectors, putting a Z there, purposely misspelling this for fun. Yes, don't yell at me. I know I'm doing that on purpose. Conversion and factors is misspelled. Get over it. Makes who puts a Z at the end of factors, alright? Oh, who cares? Alright. So we need to use conversion factors for this. So let's give an example. If we have 1 dozen, it's equivalent to 12 items, right? I can also write this as 12 over 1 dozen. This is equal to this. 1 dozen is equal to 12. It's like 1 over 1 equals 1. Right? So this has a value of 1. This has a value of 1. Because 1 dozen means 12. So if you have 12 over 12, it equals 1. Alright. If we have a pair of something, it equals 2. So you argue that equals also 1. 2 over a pair also equals 1. If I have 1 mole, now I'm going to shorten up to just MOL now, because in chemistry we can be lazy. 1 mole is the same thing as having 6.022 times 10 to the 23 atoms. Same thing. It's obviously good one because this is the same thing as this. And these are going to help us out a lot, make our math easy. Just as if I said 6.022 times 10 to 23 atoms is also equal to 1 mole. Nothing new. Alright. So we're going to use these conversion factors in our benefit. I'm actually going to leave that top up there so we can use those in a second. Draw a line. And let's actually try a practice problem. Alright, I'm going to write this down. You're going to want to write it down there too so you can reference this later on. So if you're doing your homework, you're going to want to reference this because those topics, it's going to be really hard. But as soon as it clicks, it's easy. You're like, you've been doing this in math since 5th grade. You just haven't been noticing it. Right. Say, how many moles is 4.6 times 10 to the 24 atoms? Let's say you got a bucket and it's filled with that many atoms. Let's say they're sulfur. Right. So I should actually move this. Oh. There. Sulfur atoms. So you got a big old bucket of sulfur atoms, and you know you have 4.6 times 10 to the 24 atoms in there. How many moles do you have? Okay. Well, we're starting off with this as a value we're given. That's my starting value. So I'm going to write that over here. 4.6 times 10 to 24 atoms. Alright. But I need to get 2 moles. This is what I'm looking for. Moles is my end game. So we use a conversion factor to get to that. Which conversion factor? We're not sure. So I'm actually going to just plug in a little blank here for the conversion factor. So we're going to figure out which one we need. Now our end result, we want to get to moles, but at the end. Equal blank moles. Alright, so here's the part you got to focus with. Let me actually move my little head out of the way so we can see all those. Actually, we don't need this one up here. There we go. So if we're starting with atoms, we want to find a way to cancel atoms out to get rid of it. I can pick this one or this one as a conversion factor. Either one. Since I look here, this is technically the same thing saying this over 1. I have atoms on top. If I had something on the bottom, I could cancel out. Number of fractions is, say if you have a number up here and a number down here, they can cancel. Same thing's going to happen here with units. So I have atoms on top. I want to get the conversion factor with atoms on bottom. So I should copy this over real quick. So I'm going to be lazy. Copy. Paste. All right, 1 mole. Copy. Paste. All right. So that's my conversion factor. Now, if this works right, if we have on the top of what we want, it will go over here. All right. So let's cancel out units real quick. I know that if atoms is on top, the atoms on bottom, it will cancel out. And only unit I'm left with is moles, which is what I need over here. It will work. Oh, give me 1 second. What's up?
I'm going.
Okay, I'm gonna head over that way in a bit too.
I got a doctor's appointment, that's why.
Okay. Well, afterwards I head over there and that's gonna fix the toner and grass and all that stuff. Have fun today. I don't know about the weather though.
Yeah. Well, I'll put the toner on.
Okay, well I'll get there afterwards because Samantha has the key. It's on her keyring. So I'll be there later on. I'm gonna get all these videos recorded first.
Okay.
That'll be a while. All right. Sorry about that. It's all good. Where was I? All right. So we want to always be able to cancel out units to be the unit that's left over is what we want. Right now we only have 1 conversion factor, but we can do some later on. They have 1, 2, 3, 4, 5, however many we need. Okay. Whew. Let's do some math. So if I get my handy dandy Desmos, which I don't have on this iPad, I can multiply 6.022 times 10 to the 23rd. These are next to each other. It's multiplying. Multiply it by the fraction of 1 over, I say 23rd. I messed that number up. If I multiply the number 4.6 times 10 to 24 times 1 over 6.022 times 23, put that in Desmos, which I don't have on this iPad, so I can't show you. I wish I didn't install it. I really do. It will give me the answer of 7 point something. I can't do it on my iPad, but we'll say 7 moles. We'll round it up. 7 moles of sulfur. I wish I could do that. This thing just doesn't work with the Desmos. It always works better. Okay, but y'all try it out and y'all put the full value down. Right, put full value right here. All right, that's a little hard one. Let's try something a little easier now. Let me go to a blank page. I'm going to change the background on here just that's kind of killing me. The white in my face. All right, but y'all still writing those notebooks. Now let's say I have the question: how many grams? Notice we're changing up. How many grams are there? And should be ERE or yeah ERE. Are there in 3.5 moles of carbon? All right. I know we're jumping right in there, and it's like, wait a minute, we just did the basic one. Now we're doing a little different. Just bear with me, please. Trust my process. All right, so if I have the element, I'm going to just copy over the element tile. Of course, you have one on your desk, so you don't have to do this, but I don't, as I'm at home. So you have carbon over here. Get down there. There we go. You have this already on your desk. No, you don't. There we go. So let's see, I have 3.5 moles of carbon. That's my value. And I want to get to how many grams? And that should be an S. But I want to get to this. Right, I'm going to write down first what I have. which is 3.5 grams, no, not grams, moles, MOL of carbon. Right, now I need to multiply it by a conversion factor to get 2 grams. Okay. Now I don't have a conversion factor for that has grams on there in moles. The previous page we didn't have that. We just had moles to atoms. That's okay. We can create one. So remember in this part of the periodic table we had that molar mass, or AMU, atomic mass unit. We're going to use that guy. I know that 1 mole, I'm going to change the color up here so we don't mix this up. I'm just draw down the conversion factors. Okay, 1 mole is the same as 12 grams of carbon. It's right here, 12 grams. It's the same thing. You can also write it as 12 grams of carbon is equivalent to 1 mole of carbon. Same thing. All right, so I'm going to use this guy here as conversion factor. Which one of these do I want to use? Well, let me put that over 1 because it's the same thing. If I have moles on top, I need to find one that has moles on bottom. So I'm going to want this guy. I'm going to rewrite that. So we have 12 grams of carbon equals 1 mole of carbon. Let me cancel out my units and let's see if it's what I need. All right, well, this mole and this mole cancel out. I'm left with grams of carbon. Do I need grams? I need grams. That's the only conversion factor I need. Okay, so I can do the math. Again, I don't have my decimos here, but I do have a cheat sheet, which means if I take 3.5 times 12, it's going to be 42 grams. Why is that in the wrong color? 42 grams of carbon. I can get rid of that unit there. And it's what I need. It answers it. How many grams are there at 3.5 moles? There it is. All right. So scroll off a little bit on your page or the next one. I'm going to create a blank one and try another. All right. Let's do. Let's actually go back to that sulfur one. Okay. Let's say we have, or let's convert, same terms, convert 4.2 moles of sulfur in 2 grams. Alright, I'm going to add my element tile here. Now you already have one. Remember, this on your desk. So you don't need to do this. There we go. So, let's see. We have 4.2 moles. And we want grams. And it's also going to be the sulfur. Okay, so let's write down what we have first. So we have 4.2 MOL of sulfur over 1. I'm going to multiply that by a conversion factor of something to equal grams, well, sulfur grams, yeah. And that's like 5 grams. Let me put S. There we go. So we got to find conversion. Now I know that 1 mole, let me actually write this in red, 1 mole of sulfur is the same as 32 grams. Okay. Or I can write this as 32, I should put FS, 32 grams of sulfur is the same as 1 mole of sulfur. And also, if I needed to, I could also write down 1 mole is equivalent to 6.02 times 10 to the 23 atoms. Now there's so many conversion factors in there. We're just going to use these because we know we need grams. All right, so which one of these do we need to use? We have moles on top. We want to find the one with moles on the bottom. So use that guy. Rewrite that with 32 grams of sulfur is equivalent to 1 mole of sulfur. All right. Go ahead and get rid of you guys. Let's cancel out our units to make sure we get to the appropriate unit at the end. I have a mole on top and a mole on bottom. So bye-bye. Bye-bye. I only have grams of sulfur left, and I have it here. I don't put grams of sulfur and sulfur grams. It's the same thing. You can switch them around. It does not matter. Potato, potato, tomato, tomato, pecan, pecan. Don't argue about that one. I know someone's going to argue right now. Pecan and pecan is not the same thing. Deal with it. Same thing though. But big deal is we end with grams, and we're fine. It's what we need. Let's do the math. Uh-oh, wrong page. So 4.2 times 32 over 1 is 32. Let's see, what would our answer be? All right, where's my... I'm actually going to do my calculator here. I started doing the phone, but I need to... Let's see. .2 times... All right. The answer is going to be 134.4 grams of sulfur. But I think if you use Desmos, you should get a bigger number. The calculator doesn't really do that fine detail. You might get the 134.69 if you use Desmos. But that's a big thing, so calculators are weird. Make sure you get it right. 4.2. Yeah. 134.4. If you use Desmos, it might give you a bigger detail number. It's fine. All right. Let's do one more, and that'll be it for the day, and I'll post more later on. Yeah. Let's do one more. Let's pick an element. In the element, let's do something hydrogen. Hydrogen's easy. No, don't copy. Just crop it. All right. Let's say how many atoms are in 2 moles of hydrogen? Question mark. Okay. So we're starting off with 2 moles, and we're wanting atoms. Let's write down what we have first. We have 2 mol of hydrogen. Put that over 1. I need to multiply that by a conversion factor of something where it equals atoms. Okay. Edit. Move you on down. All right, let's write down our conversion factors. We have atoms. We need moles. We have this guy down here. I know that 1 mole of hydrogen is equivalent to, well, we're looking for atoms. So let's use the conversion factor for atoms. It's going to equivalent to 6.022 times 10 to the 23 atoms, which is the same as 6.022 times 10 to the 23 atoms, or 1 mole of H. I'm actually going to delete you. And move this guy on over. Yep. So I have these two conversion factors down here. Which one do I need to use? We have moles on top. So I'm going to find the one that has moles on the bottom. Right here. So I'm going to use this conversion factor. All right, delete this one. I don't feel like writing that again because that was a lot of writing. So I'm just going to cheat this real quick. Even then, it's kind of sideways. Oop. We'll have to reset. There we go. Fix it ish. And at the end, that's going to give us blank atoms. All right. So I have moles on top, moles on bottom. I want to cancel out my units. Moles is gone. Moles is gone. Now we're going to just do the math. Now I'm not going to pop the number up here because this is such a simple one. It's multiplied by 2. To make sure you're actually doing it right when I check your notebooks, I'm going to be looking for this number right here. So what is 2 multiplied by 6.022 times 10 to 23 atoms over 1? Now really, if you're doing over 1, you don't need to put this part in the calculator. It's just 2 times this. And put your answer here, and it'll give you your amount of atoms of hydrogen. All right? So that's all the basic, simple steps. I will make another video that goes more and more practice. But this is the basic part here, doing basic conversions. So if you want some more, that's not required, but just for additional help, watch the next set of videos. Bye. Oh yeah, I forgot the annoying animation. There we go. Yay, chemistry.